Hey everyone, welcome back. Today we're going to be taking a look at refractive materials again, picking up where we left off last time and taking it a little bit further, adding some cool additional lighting features and a nice thin film effect to create this kind of bubble looking scene. So with that, we can just jump into things. So here is kind of where we're going to be going. Can see that we have a little bit more going on here, and one of the other things that I really like is if we add a light and make it red, so we can actually have TouchDesigner lighting playing with our refractive material in this setup, which is really nice, and also environment lights with PBRs, and all of this should be pretty straightforward to implement based on here, which is where we started, or rather left off last time. So if you guys haven't followed along last time, I recommend doing that, building up to this part, or grabbing the file from Patreon and starting there. I am going to be just kind of starting here. So first things first, a commenter on YouTube mentioned that there was a small correction that I should have made to my piece last week. And so I'm going to correct that now before we go forward. The first thing I'm going to do is replace my sphere with a torus. And I'll orient it along the z-axis, and maybe I'll make it a little bit smaller on this transform. Like that. Okay. And so we can start to see here an issue, which is that we are not really refracting what's behind the geometry. It actually looked better with the geometry that I was using last, so I left it this way, but it is not quite it is not quite precise. And so I'm going to fix that real quick. Get my shader over here. Okay, so what's going on? What's going on is that in our vertex shader, we're passing through this text chord, but I am not using that pass-through text chord. Or rather, we're passing through this text chord, which is the geometry texture, and that's what I'm using to look up the refracted color from the render target, which is actually wrong. I should be using screen space coordinates, so we can have a vec2 uv equals text chord.xy, and then let me turn off autocomplete. And okay, so now we can come in here and just move this to uv. So now that's working, and then what we need to do is replace our uv with a screen space. So assign screen space value to UV. And so we can do that with two things. One is a vec2, we'll call it res, and that'll be UTD. I always forget this one, so we'll go to our writing a GLSL Material, which I'm sure everyone has seen at this point from me a lot. And I know there's something called viewport, and here we go. It's this td general dot viewport, and then I'll want my x and y components. So that'll be the pixel units of my render. UTD general dot viewport dot xy, and this will be the width height of render window. Okay, and then we need our current coordinates. That'll be our glfragchord.xy. You can say uv equals vec2 glfragchord.xy divided by res. And now we see we have a little bit of a problem here, and that is because it seems like we're looking up something from these UVs, not quite appropriately. And let's see if we can figure out the reason for that. Stop this for a second. Okay, and actually, so if we go back to our here, I want this actually 1 over width, 1 over height. And the reason for that is so that we can just do a multiply here. UV equals GL frag_xy times res. And now if I go back here, okay, so now what we're seeing is actually a refraction using the texture coordinates for screen space, which means that we're basically sampling the pixel that's like right under the geometry, which is exactly what we want. One other thing is you probably want to come over here to the samplers, drop down this menu and make sure that your extend on this sampler is set to repeat, and that these extend UVs are set to mirror, and that should be all you need. So now that's a nice little fix here for the initial setup. And so now we need to do, well, now we can do whatever we want. What I want to do is now take what we're working with here and add some lighting conventions, and then also add a PBR term. Now, we could go through all of that and kind of do it here. The original blog post, which I think... So the original blog post down at the very bottom, the part that we didn't go through before, includes some code to add a specular term and a Fresnel term to this scene, which is kind of cool. It's certainly possible, and you can feel free to go ahead and do that. I can show you, I guess, really quickly how to do that, but I want to spend most of my time today working with the PBR side of things. That said, we can we'll do the specular side, because the specular side is going to end up being a little bit more interesting, and it will help us learn a little bit about the TouchDesigner side of things. So I'm going to go in here. This is all in my frag shader, by the way. I'm adding in just this function, copy and paste. We go to our info, you see this world normal we don't have. And so what I want to do is add this as another argument, vec3 world normal. And I think iVector also. Oh no, it looks like iVector we're using from our input. And so actually I'm just going to add this as another variable in the function declaration. And then I can go in here and we can add color.rgb plus equals specular. Okay, and then our ulight, we can just have a vec3 0 1 1. And then what else do we need? We need world vector, eye vector, shininess, and diffuseness. Get that out of here. Okay. So here in our specular, so we need the world vector first, which we have, so we can use world norm, and then we can use eye vector, and then we have a diffusion parameter, which we can just say are both 1 at the moment. And so now we see, we get rid of our errors, so everything's working, and now we can start to maybe play with some of these parameters to see if anything changes. Maybe I'll move my light around, move it back a little bit, and you can start to see the effects a little bit. But this is, you know, kind of weird, and it doesn't give us a ton of customizability around the lights. I would really want this for all of the TouchDesigner lights. And the other thing is this light vector is assuming that the light's going to be going to the origin. So we should be taking in actually a light position. And we should also be taking in a regular position. And so then we can use this light vector as the position minus the light position. And then in our calling of the function, we can use our the actual position of our vertex, which from the vertex shader, well, we actually don't have, but we can pass. So out vec3 world space pose, make that an in vec3 world space pose on the fragment shader, and then we'll use world space pose in our function declaration. And so I think now, again, as I kind of move the lights around manually, you can see changes, but now we want to use the TD lights. So let's go back to writing a GLSL material, and let's try and find lights. So here's what we want. We want to access this UTD lights and get the position vector for each of those lights. And the best way to learn how to do that is to actually begin our next step, which is using a PBR. I'll open the PBR, I'll output the shader, and then I'll go into the vertex shader, I'll click edit, and scroll down, and this is kind of the loop that we want right here. You'll notice that this loops through all of the different lights, and so we can just copy and paste this for loop. We can use it here. I'll just paste the whole thing in. We don't have a lot of this information, so it's fine. And so now we'll just put our specular addition in here. And I think the only change that we're going to need to make is instead of this random light position, you can say UTD lights, take the ith value of that array, and then grab position.xyz. And now, if I add another light into my scene, and especially if I don't use that light on my pre-pass, but do use it on my post-pass, we can see that we have some specular reflection coming in from these lights. And I can... Oops, not the dimmer. And so now this is working, and I think it's a good exercise to show that you can use loops like this and information from lighting uniforms to write your own lighting algorithms. However, this is not great, and there's things that we could do to make it better, like, for example, instead of the shininess set to 1 or 5, we could set it to 10, and then, okay, like there's a lot more here. And the diffuse color could be whatever, 0.5 instead of 1. Doesn't really matter. That's actually the extent that I want to go into this. Right now, I just wanted to kind of show how to use this loop and access the lighting information from the uniform. What I want to do now is continue on this PBR and basically port the stuff that we just did into a PBR shader. so that we can use all of the benefits of that pipeline in our rendering. So first things first, we need an environment map, and so for that, I'll make sure to include it. I'm just going to drop this in for now. I'll make sure to include this in the project files. This is just my classic image here. So first, I'm just going to have an environment light. We'll drop this on as the environment map to the environment light, environment map, and we will have a sphere. This is going to be our skybox. Sphere can get a transform and then a geo, and it can get a constant material that also gets this material. Now in our render, I'll call this geo skybox first, and then in our render first render pass, we'll render this instead of our skybox, or rather instead of our grid of points. This transform, let's make the uniform scale something big, like 10. And you can already see our refractive material is kind of working, but obviously this looks a little funky and not really realistic in any way. So that's what we're gonna try and make some changes with. So the first thing that I'm gonna do is open up the vertex shader of this PBR material. And okay, so here is a little bit of a hack. I like to set up a lot of my shaders this way, especially for materials. You can use this syntax if and def td, actually this is just if def td vertex shader. Then it will call this out vertex, and otherwise we want to have in vertex, because if it's not a vertex shader, it's going to be a fragment shader. End if. And so we can use this to have a couple different if-else statements that are going to basically allow us to use one shader for both our vertex and our fragment shader by defining, using these macros, which parts of the shader get compiled for each of them. This TD vertex shader is a macro that gets defined under the hood in TouchDesigner. So we can say if def TD vertex shader. Okay, we actually want this to be the same for all of them, but we want this to be over if it's a vertex shader. We say if def td vertex shader over, else, and ivert, because for a fragment shader we want it to be in, end if. And we can actually just have the semicolons up here and take it out of there. And so now this basically takes sets up a struct that has a out pre-declaration for the vertex shader, in for the fragment shader, has the same components for each of them, and also will then have ivert or overt as the naming convention. Then we do that one more time here, if def td vertex shader, and so this is our vertex shader code here. Then at the end, we just come in here, we say else, and end if, and inside here, we put our fragment shader. So the fragment shader, we can just copy all of this code, and just go right in here in the fragment shader. And the only thing that we should need to do is come in here and where is it? Yeah, so we paste this here, And then we just have to get rid of everything above this layout location equals 0. Why am I getting lost? It should just be this. This needs to go. Okay, so that's what was tripping me up. This section is all part of the vertex shader. And so now my fragment shader needs to go here. And then we need to delete this other stuff because we were already declaring all of that. And so now we have this fragment shader. Okay. So hopefully that wasn't too confusing. Now we can get rid of this and drag and drop the vertex shader on as the pixel shader, and it's all working, which is great. And the reason I like to do this is so now I just have a single document, and the uniforms are all shared, and everything else is all shared, so it just kind of makes it easier to work with. The next thing is we'll need to take these sampler uniforms and get those over here. So I'm just gonna add several of my uniforms and just kind of copy and paste these over. Right click, open the parameters for these guys, go into my new PBR, U IOR, U refract power, U samples, U saturation, and U chromatic aberration. And so now I'm just going to go through and update the values. Refract power 0.5, and then my IOR I'll drag and drop, and I'll just paste the values. So now what I can do is come to my fragment shader for the refraction material. I'm going to copy and paste my uniforms. And this looks like our new uniforms. So I'm going to, oops, I think that's the wrong one. This is the right one. Come up here and add these new uniforms. Uniforms for refraction term. So we have some of these uniforms, although sRender target is one that we need to add to our sampler here. And it looks like we have a warning. UIOR is not assigned. That's because I made it lowercase, and this needs to be uppercase. And now that seems to be working. So now what can we do? I'm going to close this, go back to our GLSL. And okay, so I'm going to copy just this sat function into my fragment shader. Outside of the main function in the fragment shader section. And then I can kind of refactor all of this into a function that's going to be called refract, and will basically just return this. So we can do that while we have this material still wired, so that we can verify if our work is correct. We can have vec3, and we call it refracted color. And so what will this take? This will take a vec3, well, we can just have it take nothing for the moment, and we can pull all of this into it. I'm going to get rid of this specular term because I don't actually care about that. We can pull all of this into it, into our refracted color. And then we just need to pass in, okay, so we'll need a vec3 I vector. We'll need a vec3 world norm. And what else do we have that's not a uniform? We'll need a vec3. Well, actually, no, because our UV is screen space, so that's fine. We don't need that. And so I guess in theory, equals vec for 0, color.a equals 1. And so now, I think if we say color.rgb equals refracted color, and then we'll pass in our I vector and our world norm, add a semicolon, and we have a little problem, and that is that I forgot to return color.rgb from my function, and so now this is working. And so now I have this refracted color function that takes in an I vector and a world norm, and we can copy and paste this function into, again, the fragment shader for my PBR material. We can redeclare our UV, so we don't need to use this reference to frag chord, which doesn't exist. And now this is nicely ported. So now we just have to figure out where to kind of implement this in here, in our PBR shader. And the answer is right here. So we can add refracted term. And so we'll have vec3 refracted equals refracted color. And at this point, we need the I vector and the world normal. And we have viewvec and normal both here, which we can just take. So we can use viewvec and world norm, or is it world normal? I forget. World space norm as our lookups, and then so what if we just said lighting color equals refracted. Okay, well now we need to drag and drop this on our shader onto our material. Or sorry, we need to drag and drop our material onto our geometry to actually start working with this now. Now that our other material is kind of being sunset. We can see this is interesting, but maybe not exactly what we like. And so I probably want to actually do some sort of mix between the refracted color and our other color. So what if we tried to do a plus? That doesn't really do a whole lot, which is okay. We can move this down. So instead of just setting this to be the refracted, maybe we want to mix using our lighting color or something like that. And so that's what we're going to try and do. So what we want to do is actually, I think, move this down. Oops. Sorry. I want to move the refraction term just down a little bit to right here after we already add the final color. And so unpause this. And instead of adding or just setting this, I want to use a mix. So I want this to be mix, lighting color, refracted, and then I'll just say 0.5 for now. Okay, so now this is starting to look more interesting, and we can also go in and change our PBR settings a little bit. So I'll make the roughness like 0.2, and we can take the alpha down to like 0.5, maybe like 0.8, and specular level can be dropped a little bit And at this point, you can kind of just mess around with some things. Maybe this roughness should be even lower, like 0.1. And now I'll add as a vector, another vector, U refract wet dry. I'll set this to 0.5. We'll come into our shader. And this is the nice part about having this set up. I can just add my uniform float, U refract wet dry. Now this is in both my vertex and my fragment shader. And now I can come back down to where we have our mix, and I'll replace my hard-coded mix coefficient with my parameter, U refract wet dry. And so now, when this is at 0, it's 100% PBR lighting. When this is at 1, it's 100% refractive lighting, which is looking pretty nice. And when it's somewhere like 0.8 or maybe 0.9, we have a refraction with just a little bit of the PBR, and that gets some nice specularity and some of the other reflections from the rest of the scene, which I think has a really nice effect. The last thing that I want to do is add some grain. And the reason for that is this looks pretty nice, but I want there to be just like a little bit more shine so that we can make it look like some bubbles. So we can start that. First, I'm going to use this curl noise. I'm going to set the curl noise to, yeah, I guess like maybe 5 by 5, 32-bit float, and we'll use a speed and a constant wired into speed, and then Alt-N for null after speed, and we'll use this to translate our curl noise in 4D. I'll set that to like a 1. Okay, so we'll come back to that shader, but for now, what I'm doing is going to set up a little instance network so that we can have some instanced geometry instead of just this torus. So we'll take a sphere. Oops, I already have a sphere. I'll just reset all the parameters on that sphere. Make sure we use an attribute create and create our normals and our tangents because we're using a PBR. And then we can go have a geo. That geo obviously will turn our instancing on. We'll use null 5 as our translate op, RGB. We'll use another noise, which I'm going to make sure is 8-bit float and monochrome, and we're going to output just the noise. And this can be our scale. And so on Geo3, we'll use our scale. So now we have some of these. And then maybe I'll increase my amplitude to like 3 on the curl noise. And now on my render pass 1, instead of just Geo2, I'll take Geo2 and Geo3. And now I'll turn off my torus render, and we'll drag and drop our PBR GLSL on our bubbles. And now maybe on the transform, I'll just knock everything down to a 0.5. And so now we have these bubbles, which are moving maybe a little fast. 0.01. Like this. This is pretty nice. Okay, so now we have these bubbles kind of moving around, which I think is pretty cool. And we can see refracting like what's around. I'll move this light a little bit also so that it is just off center. The cool thing is, because now we're using the PBR lighting, if I change the light color and the other light aspects, distant light, whatever, all of that is going to be reflected in our scene automatically because we're leveraging the PBR material. So anyway, the last thing that I want to do is I'm going to use a noise. This noise I'm going to make like a period of 8. Make sure it's 32-bit float, non-monochrome, of course. I'm going to copy and paste this speed. We're going to translate the z-axis. And okay, the other thing I'm going to do is make this big, like 4096 by 4096. I'm going to copy and paste that, and then wire the first noise into the second input. Now on this other noise, I'm going to drop the harmonics down to 1, make the period like 6, and we'll make sure that this is also a 32-bit float, which is great. Now I'm going to make the offset. Well, maybe that's okay for now. And so we can call this grain. And in our shader, we can go to our samplers. We can add another one. We can call it S grain. Point it at our grain top. And then, like I said, we would come back here. We can go up to our top. Add another sampler to D, S grain, and now we can add some grain to our image. We do want it to wrap probably, so we can just do like a quick hack with that. We can do a layout. We can then do a flip X. Put this into the layout, make sure we scale our resolution, and now we have a texture that's going to wrap nicely, and the aspect ratio matters not so much here. So we'll say vec3 grain equals texture S grain, and then what's our lookup here? Our lookup here needs to be the text chord. So we can say ivert.textchord.uv.rgb. I think that should give us what we need. No, we don't actually have a text chord set up, so we need to declare that. vec2 text chord. Again, this is the nice part. Now this is just in both of my shaders. And I can assign over.textchord equals uv0.xy. Alright, let's see what my errors are. That seems like a mistake on my part. 217 instead of UV. Let's try ST here. And now this is working. So this is sampling our grain now. And so it is pretty simple. We can just say lighting color plus equals grain. Now this is kind of insane, right? So maybe we want a parameter. U grain weight. This is another float, so we can add it as a float. Come in here and add it as a vector. Make this like 0.01. And now we're done with our code. We can change our grain weight a little bit and just kind of add some like iridescence that I think helps make the bubbles look pretty nice. The other thing, which I guess is not like terribly necessary, but we could do just to button things up is on this geo, do something like have another noise that is not monochrome, and have this maybe be the rotating function for our instances. And that way each of them will just be rotated a little bit also. And we can make that 16-bit float and make it 0 to 360. And so, yeah, now you just have like a different rotation on each of these as well. And so I think that is about it as far as this goes. You can always come back in and change your PBR again. So the roughness goes up, the reflection goes down, vice versa. All these other parameters. Oh, and make sure to turn on blending so that we can blend if you have your alpha of less than 1, which I think is kind of nice because then you get some little effects when the circles overlap each other. And we can always add our main geometry back in too to see how this all integrates. One other kind of cool note is for have multipass refractions, you can take one more render pass, boom, just like that, and we can, if we have this other set of geometry, and we copy and paste this material. We change our sampler from RT to render target 1, and then in my render pass 2, I render this new geo. Now all of a sudden we're doing like multipass refraction, which you can see introduces some artifacts, but it is kind of cool, and there's a lot to explore. I'm going to just get rid of that all for now, but wanted to mention it. And so that's it. I'll just clean this up a little bit. We'll say skybox here. This is our geometry that is refractive. This is our original refractive material. This is our PBR refractive material. And this is our render pipeline. And that's it. So I hope everyone enjoyed this. Hopefully there was a little bit of new information there. Got to learn some things. And yeah, we'll leave this here. Until next time, thank you all very much.